Can life jump planets? Panspermia is an obscure scientific word that describes the transfer of life forms, most likely tiny microbes, from one planet or moon to another planet or moon. This transfer would hypothetically occur when surface material from a planet would be ejected after an asteroid or comet impact, and then eventually settle on the surface of another planet. Scientists know that material from different planets, especially neighboring planets, is indeed shared. Asteroid impacts on Mars have sent fragments of the planet to the surface of Earth. The question remains, however, whether any life form can survive the journey, considering that the life form would have to endure extreme heat and pressure from the initial impact, live through radiation by ultraviolet photons during its journey through space, and then survive the fires and pressure of the final impact. Moreover, the journey through space could take thousands or even millions of years. While many scientists are skeptical that panspermia is possible, some believe it is not only plausible, but has already occurred. For instance, they may consider the idea that life forms on Earth originated elsewhere, perhaps from Mars. How is this possible? Recent research indicates that certain extreme life forms could survive conditions similar to those that would necessarily occur in panspermia. The most likely candidates for survival would be organisms tucked well within pockets of rocks, and likely frozen in ice. Certain forms of life on Earth have already shown incredible flexibility and toughness, including bacteria that can live in boiling, toxic volcanic hot springs, tiny water-living organisms that have been shown to endure the void of space for up to 10 days, and bacteria that have been observed on the outer rim of the International Space Station. Furthermore, organisms found frozen in Antarctic ice for hundreds of years have been revived in labs. Panspermia becomes more plausible when planets or moons are located near other planets or moons. For this reason, scientists are excited about a solar system called TRAPPIST-1, which is located 39 light-years away from Earth. In this system, 7 Earth-sized planets are packed within an area that is 20 times smaller than the distance between Earth and Mars. Such a tight grouping would increase the likelihood of panspermia several thousand times over the likelihood of life passing between Earth and Mars. 3 of the planets in the TRAPPIST-1 grouping lie within the habitable zone, where life is most likely to occur. The remaining 4 are temperate, which means that they may be warm enough to support life if they had the proper internal temperatures and atmospheric conditions. In a single planetary system like TRAPPIST-1, the interchange of bacterial life is almost inevitable, says Chandra Wickramasinghe of the University of Buckingham. Skeptics cite an obvious paradox that casts doubt on panspermia. The challenges organisms would have to endure would weed out all but the toughest of organisms. This process of natural selection would lead to the creation of superorganisms that should be able to thrive almost anywhere. However, researchers have not found any evidence that such organisms exist within our own solar system, not in rocks or soil samples from nearby planets or even our own moon.